Happy New Year and welcome to Raspberry on a Boat 8. Today we want to take a little look at NodeRED. I did a lot of NodeRED tutorials in German language. This time we will use NodeRED to replace Kplex and create an NMEA server. Let's go! So a little recap. This is my AIS HAT PCB for AIS on my Raspberry Pi 4. There's a Beam E280 I2C sensor connected, and on USB we have a GPS device to get the position. All this will now be just equipped with NodeRED. We will just use NodeRED on the Raspberry to read out the sensors and forward this NMEA converted data to external programs like OpenCPN, and this time we will install OpenCPN on the Windows machine and use the TCP server from NodeRED. Alright, we don't want to start from the scratch, just in a nutshell what you need to prepare. So you need to install NodeRED on your Raspberry, which is pretty easy. Especially if you have a modern Raspberry like a Raspberry Pi 4, go to get started on nodered.org, go to Raspberry Pi, and you just need to copy this command to your PuTTY shell and start it, and that's it. You need to start afterwards NodeRED, and the best thing you can do is to do what they suggest. You enable NodeRED as a service, so it will start after each reboot. So my recommendation, take this line as well. So you just need these two lines, this one and afterwards this one. Reboot and it's running, or if you don't want to reboot, just say sudo and then service NodeRED start, and the service is started manually, but you can just reboot because it's now always starting after a reboot. And you have NodeRED. You can simply access it via the address of your Raspberry Pi plus 18AT, and then you will see an empty flow, and we want to build this flow together today. On the other hand, I just wanted to have also OpenCPN already to see if I can get this data from the Raspberry to an OpenCPN installation. And this time I took the Windows installation, not on the Raspberry. You can do both, but I thought it's more clear to see that this is working if I get the data from my Raspberry to my Windows machine. So I installed OpenCPN on Windows. And I did what we did also in the tutorials before. I did set up already charts, so my basic charts. And that's already what you need to prepare. Of course, SSH must be enabled because we will use PuTTY. I have a non-desktop environment installed here because we don't want to use OpenCPN on the Raspberry this time. We will not use OpenPlotter at all. So SSH to work with the Raspberry, and later on we will use the NodeRED dashboard. This is existing also, and the TCP functionality to get data back to our system. So let's dig deeper into this. Last comment, if you use the WACMAT AIS HAT as like me, you can use again, we did this also, the commands from WACMAT to disable Bluetooth, to enable UART, to get the serial 0 accessible for the DAISY data. Alright, let's start with the funny part, and please ensure that Kplex or any other service is not running, because I have, for example, Kplex on this machine, and when we take a look, it's disabled. Otherwise, so you see on the Kplex, there's a minus. If it's enabled, we get in conflict with NodeRED. We want to access the same ports. Which port you know, and remember, we can do a list on our device folder, and you will see the serial 0. This is the one based on the WACMAT script which gets the data available. let's check this. You can use the command cat for that. And if I just go to serial 0, it will listen now on serial 0 and get the data which is received there. You see now there is an AIS information, and that's NMEA. And that's, by the way, a good thing that we get already NMEA data, and also our GPS mouse is using NMEA data. So we can already find the serial 0 port to get AIS data. Let's abort this one now, and let's take a look how we can find the GPS data. By the way, the first 2 letters is the type, so AIS information. Now we check the USB devices with list, so ls USB. If you have no USB connected, you should see the other 3 only. And as soon as you connect your GPS mouse on USB, you will find the device here. When we make another list, and now it's getting a bit tricky to know which device of this folder is our USB device. So that can be found usually on the manufacturer pages and so on. So I know already that the ACM0, and we did this in the last tutorial in OpenPlotter as well, we know that this is our GPS, and we can also simply test this one by, and now don't get confused, it's a lot of data which GPSs are sending. So let's take a look there, and we will get a lot of information on this level here. All right. Inputs are running. We don't need to install anything except to the WACMAT, so disable Bluetooth, enable UART, and all ports are delivering data. Now the strength of NodeRED. We can just take off the default network nodes, the serial in node. We need to define the device we want to address. So serial 0 in this case, I did this already. You might need to say add new serial port, edit, and you enter device, and then for the WACMAT it is serial 0, baud rate is 38400, and the remaining things can be kept to default. And you say done, and now let's check if it's working. We put a debug node next to our serial 0, and like on the cat command, we can connect and listen with our debug node on serial 0. Et voila, and here is the AIS information from our serial 0. Okay, and we can also use a network function, network there, to get the data out, and that's pretty easy. So we take TCP out, because it's already NMEA data, we can create a TCP-based NMEA server. We will just say listen on and take a port. Listen on because we need somebody who's connecting on this port to our TCP server. And let's take the Kplex port. What is Kplex port? 10.11.0. Kplex is off, so we can use the same port now. And this means we will have now a TCP server which can be connected on this port. So we deploy, and there's no connection currently. So you can see how many are currently trying to connect to this port. And this is already the Kplex way, right? So we take some NMEA data and we provide this NMEA data on TCP. And that's so easily done with NodeRED. Let's check this. So this is the Raspberry here, accessed by the browser. You see my IP address of the Raspberry. We go to OpenCPN. OpenCPN is running on my PC. So let's add a TCP server, network TCP server, the port which also Kplex was using. We can't use local host here. We need to take the address of the Raspberry. We are on a different machine. That was the 11 in my home network, and let's call this NodeRED NMEA TCP server or whatsoever, and press OK. And now let's take a look on you see that there's one connection. It seems to connect in a periodic way, so the connection is established and disconnected afterwards. And an open CPN, as soon as AIS data comes in, we should see the AIS information of the ships. So AIS is coming in and we see some data, but GPS is missing and we have a GPS device connected on the USB port. So let's go back to our server, and it's exactly the same way. We take a serial in. This time we need the, in my case, TTY ACM0 device. We did check this already with the CAT functionality. Maybe we could put a name on it. This is GPS, it's a Ublox device, and this is AIS. So we can see what sources we have, and you could also check this with the payload, but it's a lot of messages. We come to this point and we connect it, we deploy. If it says connected, it can find the serial port. And here you see that the connection is now nearly always on, because a lot of data is sent to this TCP port, so there's no time to disconnect. And when you take a look at OpenCPN, not only AIS is there, I got a red boat, which means I have GPS data. And you can easily see this by using the dashboard. We used the dashboard in one tutorial already. I enabled this in the plugins here, dashboard and some preferences, GPS compass status and view, just to see that it's working. You can also take time, whatever you like. And you see already on the right side, I have 13 satellites in view. And these are the satellites, so everything is working. So that's a really lovely setup, because the Raspberry is focusing on forwarding data only, and we have the PC as a powerful machine for the plotter, works pretty well. But you can do more. So this time we used the dashboard on OpenCPN. I think this is well known. We did this in other tutorials. Let's go back to NodeRED, and we do a last exercise here. For that, you need to manage your palette and install two nodes. One is the dashboard, which is usually the most common dashboard of NodeRED. That's a NodeRED dashboard, pretty famous, but not installed by default. So please install this one. I did this already. And then I found another little node, which is called NodeRED contrib NMEA. I installed this as well. And there's somebody working on parsing NMEA data to a format which is easier to handle in NodeRED, so usually JSON based. Unfortunately, it didn't work with the AIS data, but it works with the GPS data. So we can do an easy trial. We use this node, I think it's in the parser section. You can also filter for nodes that might be quicker. We go to NMEA, we remove the payload, and when you deploy this one, and you might need to delete the other messages, you will see the GPS format in a different way. So I did capture some data and I dropped the connection, because otherwise there's so much data you can't read it. And I open it, and you see there's a lot of different messages the GPS module is sending, and they always have a sentence which describes which kind of data is in. So this, for example, has nothing to do with my position. This is rather speed, sometimes number of satellites, for example 14 in view. And you will find lots of data. Take a look at it. What I want now to show and demonstrate is how to pick one and display this one in a dashboard. So first thing we need to do is we will use a switch, and we will connect to our NMEA node, and I will connect the switch to the debug window first to check if this is working. And then the first thing you want to do is we want to check if the sentence of the property is equal to, and let's take now the one with the satellites in view, for example, GSV. That's necessary, otherwise we get all sentences, and then there might be sentences without this object information, and when this is missing we would have an empty sending to the dashboard. So let's restart and take a look, and you see that we only get GSV payloads on our debug node. So we have all this data, and now let's take from our dashboard, well, let's take a gauge, and we define this gauge and say, okay, how many satellites we would expect, maybe not more, let's say, than 25. And you can say, okay, 0, that's rather bad, so that would be red. And yeah, of course, many satellites is good, it's green. And let's say up to 3 satellites, that's red, not working. Up to 5, it's yellow, and from 5 to 25, it's green. And we should put a label on it. Let's call this satellites in view. Okay, let's connect this one. Let's remove the debug node so that we have a, because otherwise you can see how many information are coming, and when you open one, it's just closing again, the next one is coming, and we need to see this in a second. And let's take a look at this one again. You need to define a group. Not sure if you did this, but that's important. You can create groups. That's just how many tabs and groups you want to see on the dashboard. Just write a name and create your first group. That's it. You deploy it, and it's not working now. It's going like crazy because it gets this complete sentence here, this complete object. Let's take a look. Dashboard can be opened, same IP address, same port /UI, or you use the direct link here on the dashboard, but it's the same. And you see it's not working. It's getting a lot of information, long sentence, and that's something it can't display. I also did put, by the way, a unit in which I just called number in this case. So we need to reduce it on one value. For that, let's take a look at the debug node, and there is these sets in view. You can also copy the value and also the path. I will take the path, and now I will go to the gauge, and instead of value, we remove this one. I will paste what we did copy. It's payload sets in view. Not sure if it needs the message in front, but it would at least work. I will try it with a message, and we got already the complete path. We say done, we say deploy, and now let's take a look, and we get a 15, so working. What we did here is we just filtered on this little object part. So on the sets of view, you can take any of those, and that's how you can build your dashboard using the NMEA data. And that is more or less the same what is shown in OpenCPN. Also there we got the satellites in view, which is also 15. But here it's based on NMEA data, and it knows where the NMEA information stores the 15. And what we did now in NodeRED is that we passed the NMEA data in a JSON object, took the sentence which is interesting for us, and from this sentence object we took the value of the satellites in view to our dashboard. Well, our time is more than used up, so it took far too long, but I hope it was interesting. And I need again to offer a second part, because what I did afterwards is to integrate my BME 280 sensor. So that is this pressure humidity sensor, but this is not speaking NMEA. So I did a conversion to create an NMEA message to get it to the TCP as well. I also pimped a little bit the dashboard. So we have the barometric pressure here, humidity, temperature, the curve with the barometric pressure, and still, of course, the satellites in view. but we also sending these converted as an NMEA message so that we can use the dashboard of OpenCPN and get also here barometric pressure and air temperature. Here again, the pressure in a different view as an NMEA standardized message. But as you can see, this is a little bit work which is still to be done, which we can't cover in 1 minute. So let's keep this for the next part. See you. Take care. Bye-bye.